Today I'm going to give you a short overview of kinematic equations that are related to acceleration. The kinematic equations apply to conditions of constant acceleration and show how these concepts are related. Constant acceleration is acceleration that does not change over time. The first kinematic equation relates to displacement, average velocity, and time. The initial displacement d0 is often 0, in which case the equation can be written as. This equation says that average velocity is displacement per unit time. We will express velocity in meters per second. If we graph displacement versus time, the slope will be the velocity. Whenever a rate such as velocity is represented graphically, time is usually taken to be the independent variable and is plotted along the x-axis. The second kinematic equation, another expression for average velocity v, is simply the initial velocity plus the final velocity divided by 2. In the third kinematic equation, acceleration is the rate at which velocity increases. So velocity at any point equals initial velocity plus acceleration multiplied by time. Also, if we start from rest, we can write a is equal to v over t. Note that this third kinematic equation does not have displacement in it. Therefore, if you do not know the displacement and are not trying to solve for a displacement, this equation might be a good one to use. The fourth kinematic equation shows how displacement is related to acceleration. When starting at the origin, d0 is equal to 0, and when starting from rest, v0 is equal to 0, in which case the equation can be written as. The fifth kinematic equation relates velocity, acceleration, and displacement. This equation is useful for when we do not know or do not need to know the time. When starting from rest, the fifth equation simplifies too. In summary, these are the 5 kinematic equations that relate to constant acceleration. Let's work on this example. The time it takes for a dragster to cross the finish line is unknown. The dragster accelerates from rest at 26 meters per second squared for a quarter mile. What is the final velocity of the dragster? This equation is ideally suited to this task because it gives the velocity from acceleration and displacement without involving the time. First thing that we need to do is to convert miles to meters. Next is we need to identify the known values. We know that v0 is 0 since the dragster starts from rest, and we know that the distance traveled is 402 meters. Finally, the acceleration is constant at a is equal to 26 meters per second squared. Now we need to insert the knowns into the equation and solve for v. Taking the square root gives us v is equal to 145 meters per second. Note that a square root has 2 values. We took the positive value because we know that the velocity must be in the same direction as the acceleration for the answer to make physical sense. Thank you for watching and see you on the next video.